Sound waves. When an object or substance vibrates, it produces sound. Sources of sound all have some part that vibrates. These sound waves can only travel through a solid, liquid, or gas. They cannot travel through empty space. Sound waves are longitudinal. A sound wave produced by a loudspeaker consists of a train of compressions and rarefactions in the air, as you can see at the figure. The speaker has a cone which is made to vibrate in and out by an electric current. When the cone moves out, the air in front is compressed. When it moves in, the air is rarefied. The wave progresses through the air, but the air as a whole does not move. The air particles vibrate backwards and forwards a little as the wave passes. When the wave enters your ear, the compressions and rarefactions cause small, rapid pressure changes on the eardrum, and you experience the sensation of sound. Speed of sound. The speed of sound depends on the material through which it is passing. It's greater in solids than in liquids or gases because the molecules in a solid are closer together than in a liquid or a gas. Some values are given in table below. Reflection and echoes. Sound waves can reflect off surface. If we shout or clap near a suitable reflecting object such as a wall or a mountain, we will hear the same sound again a little later. The sound which we hear is called an echo. We hear sound reflections as echoes. Look at the figure. The sensation of sound persists in our brain for about 0.1 second. To hear a distinct echo, the time interval between the original sound, and the reflected one must be at least 0.1 second. If we take the speed of sound in air to be 340 meters per second, the sound must go to the obstacle and reach back the ear of the listener on reflection after 0.1 second. Let's find the distance traveled by sound in 0.1 second. Hence, the total distance covered by the sound from the point of generation to the reflecting surface and back should be at least 34 meters. Thus, for hearing distinct echoes, the minimum distance of the obstacle from the source of sound must be half of this distance. That is 70 meters. This distance will change with the temperature of air. Echoes may be heard more than once due to successive or multiple reflections. The rolling of thunder is due to successive reflections of the sound from a number of reflecting surfaces, such as the clouds and the land. If the reflecting surface is nearer than 15 meters from the source of sound, the echo joins up with the original sound, which then seems to be prolonged. This is called reverberation. Limits of audibility. The audible range of sound for human beings extends from about 20 Hz to 20,000 Hz. These are the limits of audibility. Sounds of frequencies below 20 Hz are called infrasonic sound or infrasound. Rhinoceros, elephants, and whales communicate using infrasound. Frequencies higher than 20 kHz are called ultrasonic sound or ultrasound. Ultrasound is produced by dolphins, bats, and porpoises. Properties of sound. Pitch. The frequency of sound wave is what your ears understand as pitch. A higher frequency sound has a higher pitch, and a lower frequency sound has a lower pitch. Loudness. The amplitude of a sound wave determines its loudness or volume. A larger amplitude means a louder sound, and a smaller amplitude means a softer sound.